optimization problems. So I have an example here, and the question says the sum of one number x and 2 times the second number y is 90. Find x and y if the product of x and the square of y is said to be a maximum. Okay, so the first step that we are going to do is we're going to set up these equations. So the sum of one number, x, and 2 times the second number, y, equals 90. That's your first step. The second step is to set up the product equation. So you can use p or you can use any other variable, and you know the product of x and the square of y is said to be a maximum. So the product of x and the square of y. The next step is to substitute from this equation into this equation so that this equation is only in terms of one variable. So what we're going to do is we're going to set the top equation equal to x. So you have x equals 90 minus 2y. And we're going to take this x value and substitute it into this equation. So you get p equals 90 minus 2y times y squared. So now this equation is only in terms of y, which makes it substantially easier. So now we're going to distribute, and you have p equals 90y squared minus 2y cubed. Okay, so now we know that this is how we're going to find our max. So what you know is that when you take the derivative and you set it equal to 0, that's how you find your relative max and min. So that's the next step we're going to do, is we're going to take the derivative of p and set it equal to 0. So you know p prime equals 180y minus 6y squared. So this is the derivative, and now we're going to set it equal to 0. So 180 minus 180y minus 6y squared equals 0. Now we're going to solve for y. So you can take out a 6y from both, and you'll get 30 minus y equals 0. Now using our algebra, we're just going to solve for y. So you have 6y equals 0, which means y equals 0. And 30 minus y equals 0, so y equals 30. So these two values are our relative max and min. However, we do not know which one is the maximum, which is what we're trying to find. So we're going to use the second derivative test to find out which one is the maximum. So we're going to take the second derivative of this equation. So we're going to get 180 p double prime equals 180 minus 12y. So this is the second derivative of our p equation. And now we're going to plug in these two values for y to figure out which one is the max and which one is the min. So p double prime of 0 equals 180 minus 12 times 0, which equals 180. So by the second derivative test, since this is positive, that means that the equation is concave up, like that, which means this value, our 0 value, would be a relative min. Now we're going to plug in, just to make sure, our 30 value. We'll get 180 minus 12 times 30, which equals negative 180. Now, by the second derivative test, since this value is negative, that means this equation is concave down, making this value, our 30, a relative max. So now we know that our 30 value for y is our maximum. So we have this value, and now we just need to put it in this equation to find our x. So x plus 2 times 30 equals 90, x plus 60 equals 90, and x equals 30. So we get x equal to 30 and y equal to 30. And that's how you do optimization.